So we know a little bit about linear kinematics, right? Kinematic equations like delta x. I actually won't write like that. I'll write let's do that junk. So x is equal to 1/2 a t squared plus v naught t plus initial position, right? And maybe let's see here, v squared is equal to v naught squared plus 2a times final position minus initial position. We know about things like that. But what's really interesting is that for angular stuff, angular kinematics, these equations are basically copied and pasted, right? So instead of having x's, right, you can see this. Instead of having like x's and stuff, we have like theta, right? Maybe theta is equal to 1/2 alpha t squared plus omega naught t plus initial theta, right? And the reason for this is that, well, we basically look at the same starting materials, right? So basically, one day some guy a million years ago thought of the idea of position, right? And then decided that velocity would be equal to the rate of change of position. And then decided that acceleration would be equal to the rate of change of velocity, right? And then decided that, all right, we'll have the condition that acceleration is constant, right? So with these starting materials, with this given information, using mathematical logic, we can come up with these equations. So the reason why it works for angles too is that, well, we had the same starting materials, right? We defined something called, I guess, angular position, which is just the angle, just the angle, right? Angular position, angle, alright? So we just defined an angle, right? Angular position. We defined angular velocity, omega, which is just change in angle, change in theta over change in time. We defined angular acceleration, which is equal to change in omega over change in time. We made the assertion that alpha is going to be constant, angular acceleration, right? So exact same starting materials, just with different names. And if we play the same mathematical logic, it makes sense that we're going to get the exact same equations. So it makes sense that this equation and this equation are basically going to be copies of each other, just with different variable names. Therefore, we can also say, if we have this equation in like the linear world, we can say that for the angular world, omega squared is equal to omega naught squared plus 2 alpha, theta minus theta naught. Right? This makes sense. This is perfectly valid because we have the same starting materials. We use the same mathematical logic. So that's basically it. Linear equations, angular equations, copy and paste with different names. And that's the reason why, in my opinion. I think that's a good way to think about it. If you like this, follow for more things and follow for more things like this. If I made any mistakes or you have better insights, put them in the comments. I'll see you in the next video, whenever that is.